Welcome back to another video, guys. It's just math, y'all. We're going to learn how to add rational expressions, and if you don't know how to add fractions, you'll learn that as well. So let's jump in and see where we're at. Okay, so we're going to learn how to add and subtract rational expressions. Okay, in the last couple of videos, we've been finding the common denominator. Okay, so this one we're going to understand that you have to know the common denominator first. So, adding, subtracting rational expressions having the same denominator. Well, anytime you have the same denominator, then you just add the numerators. You just combine the numerators. So if you have regular fractions or not regular fractions, if the denominators are the same, you just combine the numerators. It's just that simple. And so for this first example here, I have the denominators are the same, so I'm just going to combine my numerators. So a 5x and a 3x combined to give me an 8x, and a 2 and a negative 7 combined to give me a negative 5, and then the denominator stays the same. So that's how you add fractions when the denominators are the same. Okay. But if they're not the same, you have to get a common denominator first, and then you do what we say in part B. Okay, so part B. Add rational expressions having different denominators. First, we're going to factor each denominator and find the LCD. Notice we don't have to do the numerators this time, but factor each denominator and find the common denominator. Okay. Then you're going to change the numerators by multiplying by the missing factor. Okay, so we'll go through that slowly again in a little while so that you can help see what in the world these steps mean so that you can use the steps to help you go through a problem. And then step 3, you add or subtract the numerators together. Watch out for the subtraction. Okay, so the first thing we need to do is find the LCD. And so for 3 and 7, they don't factor, they're prime. And so when I need the LCD of prime numbers, I just multiply them together. So the LCD for 3 and 7 is going to be 21. So what I do is each one of these fractions has to be changed so that the denominator is 21. And if you'll know, 21 is 3 times 7, right? So now I'm going to multiply the numerators. I'm going to change the numerators by multiplying by the missing factor. So for the first one, I'm going to multiply it by 7 because it was 7 that was missing, and 1 times 7 is 7. The second one, the 3 was what's missing, and so I'm going to multiply my numerator by 1 times 3 and get to 3. And then step 3 says add or subtract the numerators together. 7 21st plus 3 21st is 10 21st, and that's my answer. Let's do another one. This one, the common denominator of 5 and 15 is 15. So the common denominator is 15. And so I don't have to change the second one. I don't have to change it because it already had the denominator I was looking for, so I don't have to change it. But I do have to change the 1/5, and I multiply it by the missing factor. Well, 15 is 5 times 3, so multiply the numerator by 3, and then I can subtract. 3/15 minus 4/15 is a negative 1/15. All right, go a little faster. Common denominator for 6 and 4. Common denominator 6 and 4, going once, going twice. Oh, it's 12. Okay, and so now I'm going to change the numerators by multiplying by the missing factor. Okay, so I'm going to change the numerators. So 6 has to be multiplied by 2 to get 12. So multiply the numerator by that missing 2. So 1 times 2 is 2. And 4 has to be multiplied by 3 to get 12. So multiply the 3 times 3, I get 9. Now I can add 2 twelfths and 9 twelfths is 11 twelfths. And that's there. Guys, I know I'm going really fast. If you need to go back and figure out how in the world I got 12 for the common denominator, please go watch that previous video. Or if you have questions, you know how to get in touch with me. Okay, so now let's do these same steps with rational expressions. Okay, so factor each denominator and find the common denominator. So now when I'm looking at 6x and 3, remember we said that when we did the denominators, we take all of the first one and then go to the second one and see what else do I need. I don't need anything else. My common denominator is 6x. This is my common denominator. Okay, so since the common denominator is 6x, then I'm not missing anything here, and so I don't have to change anything. For step 2, I don't have to change anything. Okay, but what's missing from 3 turning into 6 is a 2. So I'm going to multiply this one by 2 on top. 1 times 2 is 2. And then I can add them. 7 over 6x plus 2 over 6x is 9 over 6x. Okay. All right. Amber alert. You know how it goes. Okay, so now this next one, the common denominator for 5 and 6 would be 30. The common denominator for 5 and 6 would be 30 because you'd actually multiply those. And then when it comes to the numbers, sometimes you multiply the two of them, like we did in example 2. Sometimes you only have to multiply one of them, like we did in example 3. And sometimes we multiply both of them by something to get the common denominator. Remember, the common denominator is the number that all your denominators go into. So the common denominator here is 30x. Okay, so now we multiply by the missing factor. Step 2 is the key to getting these right, multiplying by the missing factor. To get from 5x to 30x, I have to multiply by 6. So I'm going to do the numerator by 6. Ooh, a little distributive property going to happen there. And the missing factor on the bottom is 5. So I'm going to multiply the numerator by 5. And then I'm going to have to combine my like terms. I'm going to have to add or subtract. Well, this time was just combine. So we're going to combine them. So I have 6x plus 18 plus 15x plus 25. And all of this is over my common denominator of 30x. Let's finish this up. And I'm going to get 21x plus 43 over 30x. There we go. There's my answer there. Okay. Adding and subtracting rational expressions with different denominators. Go through the steps. Find the LCD first. Change the numerators through multiplying, and then you can combine the numerators. All right, guys. It's just math, y'all. Got some more examples coming up in the next video. You can copy those down, and we'll get to them as soon as we come back.